Assalamualaikum students, how are you all? Hope all of you are fine. I am Theba Mahmood, your chemistry teacher, and today we are going to discuss about our topic which is known as the vapor pressure. In yesterday lecture, we have studied about the evaporation, and all of you are very well familiar with evaporation. That evaporation is the changing of liquid into gas from the open surface. And yesterday we have studied about its different factors which are including the surface area, temperature, intermolecular forces. And now we will discuss about the vapor pressure, and vapor pressure is a new topic for you, and it is a very interesting topic. Let's first we will go towards our moral lesson of the day, then we will start our lecture. Okay, and now the moral lesson of the day is the trust on Allah and never lose hope. So students, it is a very good lesson, or it is a very big lesson for you, that you never lose your hope on Allah. You are always committed with Allah, and you always trust him, and you never think that things never things are going wrong, and they never going to be good, because these are all the things which come in our mind due to the evil things. So you will never lose your hope, and you always trust on God for the positivity side, and you think that certain positive things will happen in your life. Okay, boys and girls, now today we are going to discuss about the vapor pressure. And vapor pressure, before going towards the vapor pressure, girls, let's see, consider a simple example. Okay, girls, your today's task is that you will take a bottle, ordinary bottle. It is maybe of the Pepsi or Coke or whatever, Sprite, or big or small plastic bottle जो आपके पास mineral water और कोक की bottles होती हैं. You will take any bottle of them, and you will add the warm water in it, not too much hot water. No, girls and boys, not the hot water too much, but it is a slightly warm. Slightly warm mean not so much hot and not so much cool. It is mean warm. If you feel it, it should be warm. Okay, you will add this water into the bottle, and you will close the lid of the bottle. Okay, at last you will see that if you pinch the bottle, it will go on pinching. It will press from if you press the bottle. But after some time, if you shake the bottle, you will not fill the bottle up to the mouth of the bottle. You will take a half bottle or less than the half bottle, and after some time, when you shake the bottle with the warm water which has in it, you will see that bottle will become stiff. Bottle जो है वो stiff हो जाएगी, and you feel difficulty in pressing that bottle. Okay, now what happened that before few seconds bottle is compressible, and after few seconds it will become stiff, and we will not able to press it easily. Now girls, what is this? This is actually the vapor pressure, which is caused by the vapor of the liquid on the liquid surface. Okay, this is known as the vapor pressure. So girls, vapor pressure, we said that as you are seeing with its name, you are understanding from its name that vapor pressure mean the pressure exerted by the vapors. Okay? And vapors of what? Vapors of the liquid. Okay, so here is its definition: the pressure exerted by the vapor of liquid at equilibrium with the liquid at a particular temperature. Mean girls, pressure exerted by the vapor of liquid. Okay, what is vapors come from where? Liquid. Vapor of the liquid, and it is exerted on the liquid. Okay, vapors, the pressure of vapor exerted on the liquid, ठीक है, at a particular temperature. ठीक है, we will not increase the temperature of the liquid. When you add the warm water in the bottle, then you will not heat up the bottle. You will these processes goes on at a particular temperature. Either it will be 25, it will be 30, it may be 35. We will not change the temperature. So we can say that vapor pressure is the pressure of vapors on liquid at a particular temperature, and this will occur in the equilibrium state. Okay, so girls, boys, here is a state in which liquid will change into the vapors, and vapors will again change into the liquid. As we know that liquid change into the vapor is known as vaporization, and when the vapor change into the liquid, it is known as a condensation. Got it, girl? So the process of condensation and the process of evaporation will go on side by side. Now, what is the dynamic equilibrium? Dynamic equilibrium is a new word for you. Here is the dynamic equilibrium. Boys and girls, as I already tell you the small example of the bottle containing the hot water, here is the same phenomena is discussed in this dynamic equilibrium. So what they are saying when we will take the warm water in a open flask, what happened, we will take the water in the open flask, the vapors of the liquid will form and they will mix up in the air. Okay, got it? Mix up in the air, there is no pressure of the vapor. Okay, now girls, what has happened now, if we will take the water into the closed surface and we will take it into the we will take the water into the closed surface and we will close the lid of the bottle, then what happened that liquid will vaporize. Okay, at the start the liquid vaporizes and it will exert the pressure, it will vaporizes and it will go and mix up in it will go up. Okay, after some time what happened that the vapors that are condensing on the liquid surface are more as compared to the vapors that are coming back to the liquid. So at the after some time you will see that the rate of vapor forming is equal to the rate of the condensation. Girls, what is condensation? When the liquid vapors go on the upper surface of the bottle, they will become cool and they will come back to the liquid surface. So vaporization is changing of liquid into the vapors. Vapor will form, they will go on the upper surface, and now lid is closed. These vapors will now condense on the upper surface of the bottle and they will come back to the liquid surface. Okay, liquid is changing into vapor and vapor is changing into the liquid. Then a stage reaches when the rate of evaporation and rate of vaporization become equal to each other, and now we will say that the dynamic equilibrium is established. Okay, see the diagram. Here we will see that in the first diagram, in the first figure, you will see that only the 4-5 particles of the water will go up. Okay, but after some time you will say that many particles of the water is vaporizing and they will coming back also. Here is a some particle which are you saying that if you see the arrows of the liquid, you will see that these vapor water vapors will coming back. So we can say that in the second diagram the rate of evaporation is equal to the rate of condensation, mean the water molecule which are changing into the vapors is equal to the rate of vapors that are changing into the liquid. So we can say that now dynamic equilibrium is established. Got it, boys and girls? Now girls, here is a some factor which affect the vapor pressure. First of all is the nature of the liquid. First of all girls, in chapter 4 you are studied about the liquids maybe of or two types. One is a polar liquid, another one is a non-polar liquid. Okay, now what is a polar liquid and what is a non-polar liquids? Girls, polar liquids are those in which are formed between the which contain the two different atoms in it, and the non-polar liquids have contain the same type of atoms in it. Now boys and girls, the vapor pressure of the polar molecule is low as compared to the vapor of the non-polar molecule. In non-polar molecules the intermolecular forces are weak, but in polar molecules intermolecular forces are strong. Okay, so in polar molecules have the strong intermolecular forces, so it is difficult to weak that forces and it is difficult to make the vapors of them. So there, when the vapors are less, then the vapor pressure is also less. Okay, example is water and alcohol. Water has a strong intermolecular forces. Okay, you have studied it in the hydrogen bonding. If you remember in chapter 4 you have studied that water has a high boiling point and the alcohol has the low boiling point. So in other words you can say that water has a strong intermolecular forces, so it will exert less vapor pressure, and alcohol has the weak intermolecular forces, so alcohol molecules will break easily and they will form more vapors and more vapor pressure will be exerted by alcohol as compared to water. Now here is another factor which affect the vapor pressure. Now it is the size of the molecule. We will say that small size molecule will easily evaporate than big size molecules. Okay, so the small size molecules will easily break down. Okay, and it will go into the breakdown, and they will convert it from liquid to the vapor. When vapor are more, then vapor pressure is also more. Okay, and in the big size molecules is not easily break down. Okay, and what happened that it will not break down easily, and it will not exert the more vapor pressure. Here is two examples. One is a molecule which is hexane. Hexane molecule mean a molecule which containing six carbon in it, and the other molecule is decane. Decane containing the 10 carbon in it. So we can say that hexane has more vapor pressure than decane. C10H22 is decane. Okay, now why the hexane has a more vapor pressure and decane has less vapor pressure? Because hexane is a smaller molecule, it will evaporate easily. When it will evaporate easily, it will form the more vapors, and hence it also exert the more vapor pressure as compared to decane. So hence prove that small size molecules have more vapor pressure as compared to big size molecule. Now here is the last factor which affect the vapor pressure. It is a temperature. At high temperature the vapor pressure is more than at the low temperature. Okay, why at high temperature, why the vapor pressure is more? Because at high temperature the kinetic energy of the molecule is high. Kinetic energy is the energy of the molecules due to their motion. When they have the high kinetic energy, they will easily vaporize. When they vaporize easily, they will exert more vapor pressure. Okay, and as compared to the low temperature, so we can say that at high temperature molecules evaporate easily and they exert more vapor pressure. Why they exert more vapor pressure? Because they have high kinetic energy. And at low temperature the molecules do not have the molecules do not have high kinetic energy, and they will not exert more vapor pressure. Okay, and here is a table which shows the relationship of the vapor pressure of the water with the temperature. Okay, here is they will take the liquid water, and they will tell you the vapor pressure at different temperature. So first of all, at 0 degree centigrade the vapor pressure of water is 4. Then if we increase the temperature to 20, the vapor pressure of water is 17.5. Then if we increase the temperature at 40, the vapor pressure is 55.3. And if temperature is 60, the vapor pressure is 149.4. And if the temperature is 80, the vapor pressure is 355.1. And if the temperature is 100, the vapor pressure is 760. So what is proved from this table 5.1? That if we increase the temperature, vapor pressure also increases. Okay, now students, your homework is to learn the vapor pressure. I will listen from you the vapor pressure on tomorrow, and tomorrow we will study about the a new topic which is the boiling point. Now what is the boiling point? You are listen about that. The boiling point, the water is boiling, the milk is boiling, everything is something you can say is boiling. So how the boiling is caused and how it is formed, we will discuss it in the next chapter. Okay, that's okay for today, students. Take care and Allah Hafiz.